Hello, everyone. This is Yao Lei. I'm a validation engineer from Intel. And today our topic is the using 4K page in DPDK. And this work is done by, with me and my colleague Hu Jiayu. So our topic is first why we try to enable 4K page in DPDK, and what is the performance bottleneck if we using 4K page, and what's the performance result with different workload in DPDK, and how to improvement we will introduce some potential way to improve the performance. First, why we use 4K page? We know that DPDK is always designed based on huge pages to achieve best performance, but if we using 4K page, we also can get some advantages. For example, it's flexible. I heard that a lot of one is complaining that DPDK is greedy of memory. So 4K page can be allocated on demand, and no memory need to be preserved when system start up. The second reason is the security. Now almost all the DPDK application is run by the root mode. So if we bring 4K page to DPDK, it has possible we can run with DPDK application with non-root mode, and it will bring us some security assurance. So, but now why 4K page is still rarely used in DPDK, even we have introduced it in DPDK 17.11. I think the most reason is the performance. So first, let's see how we can use pure 4K page in DPDK. First, we need to turn on BTD in BIOS, and we need to set the transparent Hugepage to never and Intel MMU on in grab. Then we should utilize the VFL PCI driver. We should bind our NIC to VFL PCI and send no huge command to the EAL to let DPDK set to the LVA SVA mode. Then the 4K page-based LVA address will be translated to PA by Intel MMU. The sample command is here. So let's see a very simple test topology using DPDK is testpmd with two NIC banded and dual forward. And each 40 gig NIC will connect to Asia, and Asia will generate IMAX packets. So the first impression is that 4K page is very low performance, right? Even both in MPPS and GBPS result. This is the first preference. So we will try to see why cause this low performance and what is the performance bottleneck. The first potential bottleneck is the TLB. So for the VA to PA address translation, each MMU will have TLB. If we using 4K page, if we don't have enough TLB entries, the TLB miss event number will increase. The second is the IOTLB. MMU need to translate the LV address to physical address, and this MMU is per socket. So if we using 4K page, this IOTLB may have the miss event. The second is the UPI. We know that if we using huge page, we can always DPDK can always make sure it's NUMA aware, and we always use the local memory. But if we use 4K page, we lost this advantage, and in worst case, all our memory access may be remote in multi-socket architecture. So first, let's check the TLB in this test scenario. So we can see that the DTLB miss event number is much higher than in 4K page is much higher than 2 meg huge page, but the total miss rate is still low. So we think that the TLB is not the bottleneck in this test scenario. Also, we check the UPI. So we try it on the Intel latest Xeon processor, Platinum 8180. So we only see around 3 performance drop if we use all remote memory. The answer, we think the performance bottleneck is the IOTLB. So in this picture, we can see from the latest Intel processor, we can use a processor counter monitor to trace the IOTLB miss event numbers. And from this table, we can see that if you're using 4K page, the TLB miss event is huge than huge page. So this is Next, so we know that in that test scenario, 4K page have very low performance compared with huge page. But that scenario is too simple, and it always a lab scenario. So let's see what in the real world. So we test got performance for several test scenarios. The first is DPK physical to physical. We listed in previous slides, and we also try with OVS DPK with 1 flows and 1 milli flows for this NIC forwarding. Also, we try DPK PVP scenario. This means the packet will go to the NIC, then go to the VM through the host IOU the port, then back to the NIC in the host. Also, this test scenario also be used try in OVS with 1 flow and 1 milli flows. So in this case, we can see that at the right side, if we don't involve vHost IO, huge page have performance advantage than 4K page. But if we involved vHost IO and the VM involved, 4K page and huge page almost have the same performance for single core performance. So we can see that in real world, we may have IO bounded scenario, CPU bounded scenario, or memory bounded scenario. So memory bounded scenario, obviously, we will use huge page. But for IO bounded CPU bounded scenario, we think that 4K page still can be used. And for the IO bounded, we will discuss more later. So the question is, in IO bounded scenario, is 4K page lack performance for all packet size? In this table, we can see that for the larger packets, 4K page still have good performance. But the worst case is in packet size 60 and between 60 to 200. So we will see, is there any potential way to improve this? First idea come to our mind is that if the low performance bring by the IOTLB miss event, so can we reduce it? The IOTLB is translate the packet received from NIC to the physical address. So if which bring this IOTLB miss, the reason is the NIC TXT and XT numbers. Default in DPK is the NIC TXT RD is in testpmd is 1000. So if we reduce the NIC TXT and XT to 128, we can see big performance, and the IOTLB miss event reduce very quickly. But do you think it's a good idea? I think no, because in real world we can't reduce NIC RXT and TXT to such low level, and also we will always use multi-NIC and multi-queue. So seems we can't reduce the IOTLB miss event if we're using 4K page. Another idea is that because not like the huge page, because huge page do not have IOTLB miss event, and IOTLB will do the address translation for both RX and the TX side. So if we have much higher pressure on RX side, the TX throughput will be impacted heavily. So this is the table with we inject 80 gig throughput to the RX side, and compare with we run zero packet loss. In zero packet loss, the RX will always be equal to the TX. So we can see that if we reduce the RX rate to balance the TX throughput, we can almost get triple performance gain on the small packets. Also, if we can't reduce the RX pressure at the NIC side, we may reduce RX pressure at the CPU side. We can let CPU fetch the NIC RX distributor a little lower. Also, in this scenario, for the testpmd IO forward, we add about 2 microseconds delay to the CPU. That means CPU will fetch the NIC a little slowly, and we can see huge performance at different small pack size. Also, we always know that we have transparent Hugepage. So we also try some test scenario with transparent Hugepage, but we can see some unstable performance gain at a small packet size using transparent Hugepage. But if we inject with IMX packets, we don't see obvious performance change. Also, we found that the transparent Hugepage can reduce the TLB miss rate to a very low level, but the IOTLB miss event rate is still very high. Also, transparent Hugepage can bring some side effects. For example, it will have some fake memory leak behavior in some worst cases, and the default transparent settings in latest kernel is set to MetaVice instead of always. So I think the key takeaway today is that if we're using 4K page, the IOMMU is the performance bottleneck. And only in IO-bounded scenario, 4K page have some performance concern. Also, if we are in IO-bounded and using 4K page, we can reduce the access rate to get a relatively high total system throughput. This is my topic today. Thank you. So, any questions? I think it depends. We always try to use 4K page for the forwarding core in DPDK. So if you are related to VM application, it depends on application itself. If you are running a database-like application, obviously you need Hugepage.
Yeah,
I think in our test, we are just using the 4K page in forwarding core such as OVS DPDK. So,
okay, but there are different implications if you have more processes using DPDK.
Yes.
Because you require different IOMMU mappings. So the test with maybe 2 ports is fine, but you have different different processes, then the IOMMU TLB contention is going to be higher. So how many different, because just one process or 2 processes is easy, but if you have...
Yeah, I understand the question. The problem using IOMMU is that the performance can't be scaled. So because the IOMMU is per socket, you mean that different core will both share, different device will share both the IOMMU device on the same socket, right? So we just test a multi-NIC scenario, but we don't using a lot of different applications.
No, that's fine. I think we can go back. No, that's fine. No, I think that all the point about 4Ks on Hugepages is that if you have a small pages map in IOMMU, and you have different applications, that is the usual case for servers. You have VMs, and each VM is using its own IOMMU mapping.
I think IOMMU mapping is maybe should be per device. If you have more devices, you will have higher pressure on IOMMU. So
no, the IOMMU mapping is per
Yeah.
VM or per DPDK application.
Yeah.
So the more VMs, the more
Yeah.
IOMMU mappings, the more IOMMU contention. So maybe the 4K thing works for one VM or two VMs, but you have, let's say, 16 VMs per Newman node in a system, then the small pages are going to be completely...
Yes, because, I understand. Because in our test scenario, we are always thinking some cloud. Your scenario, cloud is based on, a lot of cloud is based on vHost volatile ports, so they don't need IOMMU involved in the VM communication. So your scenario may be the VF SRV scenario, I guess, right? So if you are thinking, so I know that 4K page don't suit for all scenario, but for some cloud scenario, because they only have 1 or 2 NIC per socket for the physical port, and they're using 2 ports for the forwarding core, and other ports are based on vHost for I/O. So in this scenario, we are thinking 4K page have possibility to be used, but obviously 4K page can't be used in all scenarios.
Okay, thank you.
Thank you.
Okay, thank you very much. If there's no other questions, Thank you, Yao Lei.